like that she's going to give you. How many, for those of you who know about cards, how many total cards are in a deck? There's 52 total cards in a deck. Okay? How many, okay, so we have the hearts, we have the diamonds, we have the clubs, this is why I'm not drawing, we have the spades. How many are in each suit? How many hearts do we have? We have 13 hearts, we have 13 aces, we have 13 spades, and we have 13 clubs, which add up to the 52. Now, these at the end are called face cards because they have little faces on them. Who would have thought? Okay, so when we talk about cards, we have the ace through the 10, and then we have face cards. Okay, and you'll be given this paper, and we'll be pulling this page up over and over again so that you can get used to it. Half the cards are red, so 13 plus 13, there's 26 red cards, and then there's 26 black cards. Okay, and we'll use this over and over again to talk about probability, because when you're gambling, this is a big part of probability. So this says drawing a pair of kings from a regular deck of cards. So I want to know, is it an outcome or is it an event?
It's an event.
It's an event because I could draw him and be happy. So I can draw a king of, pretend, cauliflower and a king of spades. Or I can draw a king of hearts and a king of diamonds. Or I can draw the king of clubs and the king of hearts. As long as I have more than one set to make me happy, it's going to be an event. Yay? Okay? Alright, so most of us know about probability. If I said, what's the probability that it's going to rain today? Or it's going to snow today in Florence? Zero. Zero means it ain't going to happen. Okay? What's the probability that I'm going to go to a softball game this afternoon?
Pretty high.
Pretty high. Okay? So on a chance, zero means it ain't going to happen. 50, and this is 0.5 or 50%. So this is as a decimal. 1/2 is as a fraction, and this is as a percent. We'll do the whoop whoop, the math enter, just like we've always done. This is 0, 0, and 0. Okay? It ain't going to happen. 50 is a 50-50 chance, and it's going to happen. Like, what's the chance that y'all are coming to my math class today? You here. So 100% it's going to happen. Okay? We know that much about probability. There are 3 types of probabilities that we're going to do. There's theoretical, there's relative, and there's subjective. Theoretical is what should happen. Relative is what does happen. And subjective is what your gut says. And we're going to talk about all 3 of these. Theoretical is what should happen. Relative is what does happen, and subjective is what your gut says. And the directions kind of tell it to you theoretically. In theory, this is what should happen. Relative is what does happen. If I do an experiment, this is what happened when I did it. And subjective is what my gut says. When y'all took that test last week and you were telling that tutor to submit it, you knew what your gut says. You knew your, oh, I think I did good, or your gut says, what's the probability that I'm going to get married this year?
0.
There you go. What's the probability that I'm going to have a baby this year?
Absolutely.
Even less than 0. Better knock on wood with that one. So theoretical is what should happen, relative is what does happen, and subjective is what your gut says. So we're going to start out with theoretical. And like I said, theoretical is what should happen. Theoretically, what should the probability be? Now, they give you all kinds of crazy formulas. Miss Cooper ran into crazy formulas, okay?
Thank God.
The probability, and this is probability, the probability is what makes me happy over the total. I'm all about what makes me happy. What makes me happy over the total. Anytime I hear probability, I'm going to say what makes me happy over the total. Probability is what makes me happy over the total. So this whole chapter, anytime you see probability, you're going to say, oh, that's what makes me happy over the total. What makes me happy over the total. Now, I guess I should have known a long time ago that I was going to be a math teacher, because I remember being little and thinking, I mean, not mathematically thinking, but thinking, I wonder what the chances are that I meet somebody with the same birthday as mine. Like, I remember that being really little. I guess I'm just weird like that. But it says, suppose you select a person at random from a big group at a conference. What's the probability that the person selected has a birthday in July? Assume that there are 365 days in a year. So, what's the probability that I just walk up to somebody and they have a birthday in July? Not even the same day as me, but just the same month. Well, first of all, y'all, you have to know how many days are in July. And me and my husband fight about this all the time. Like, not really fight, but he just thinks I'm stupid. Okay? So, we try to teach my daughter how to figure out how many days are in a month. Which Madison will go to her iPhone and just say, look at a calendar, Mama. You're an idiot. So, when I learned the months, I learned a little jingle. 30 days have September, April, June, and November. All the rest have 31 except for February. That's the time when February's days are 29. And Jody's like, what? And my husband learned the knuckle trick. January, February, March, April, May, June, July, August, September, October, November, December. Okay? If you're on a knuckle, it has 31 days. If you're in the valley, it has less than 31 days. I know people are already looking at their knuckles. So January has 31 days. February has less than 31 days, so 29 or 30. January, February, March has 31. April has less than, so 30. May has 31. June, July, August. So July and August are the only 2 months back to back with 31 days. September has 30. October has 31. November has 30. December has 31. So for this problem, we're doing July. So January, February, March, April, May, June, July. July has 31 days. So every time we're counting up and saying what month, blah, 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 I start with 30 days, have September, April, June. He's going, so now you've learned something new. So we just now know that July has 31 days. Most people don't want to do my little thing. They now do this. Some people still go to their iPhone to look at their calendar. And while I'm doing that, do y'all know that you can do your 9 times, if you have children, this is cool too. You can do your 9 times tables on your hand.
Yeah.
That's how.
Taylor was showing me, I forgot.
Like 9 times 3. You hold down, this only works for 9s. You hold down your 3rd finger because it's 9 times 3.
Yeah.
It's 27. 27.
Oh, yeah.
9 times, give me a number.
5.
So you hold down your 5th finger. 1, 2, 3, 4, 5. So it's 45.
Dang.
9 times 8. 1, 2, 3, 4, 5, 6, 7, 8. 72. That's all.
I struggled so bad with that in elementary school before
Yeah.
calculators and everything were invented.
I know. All right, so we now just learned that there's 31 days in July. Now, because the problem says probability, the probability means what makes me happy over total. So what's making me happy is a July birthday. So how many July birthdays are there?
31
There's 31 July birthdays.
out of 300.
Out of the total birthdays in a year are 365. So if I go to my calculator, and there's 31 July birthdays out of 365. So if I do math, enter. So, y'all, this is my decimal answer, 0.0849. This is my fraction answer. So if I whoop that, whoop, the percentage answer is going to be 8.5. So there's an 8.5% chance that I walk up to you and your birthday's in July. Theoretically. Isn't that cool? So, my birthday's May 10th. What is the probability that I walk up to another person and their birthday's May 10th? How many birthdays would make me happy? One. Because I'm only happy if I hear May 10th. So one birthday makes me happy, and how many birthdays could I hear? 365. So one birthday makes me happy out of 365. So the probability, let me pull this over so I'll have it. So the probability of hearing my birthday is 1 out of 365. So what's the percent that I'm going to hear my birthday?
That's
If I do a whoop whoop,
the
0.27. Less than half of a percent. There's a 0.27% chance that you're going to walk, about 1/4% chance that I'm going to hear you say, "Oh, that's my birthday too." So what's the probability that you're going to hear your birthday? The same thing.
So if like you wanted to know how many people were born on your like month, day, and year, not just your year,
Oh, boy, you're getting
how would
really
you figure
big.
that out?
You're going to have to say, now you would have to know in like a span of time, because you would have to not only count the 365,
You have to count years.
right, so it would be 365 birthdays in 1990, 365 birthdays in 1991, 365 birthdays in 1992, 365, so if you go all the way back to the beginning of time,
What if you just, okay,
so like if you did in the 70s or if you did in the 80s, then you could do 365 in 1970, 365 in 1971, 365 in 1972. You would add up all of those, and you would do 1 out of all of those.
And it would be .000.
Right? So you're probably, so if you meet somebody who was born on the same day, month, and year, you better buy a lottery ticket.
Yeah.
I went to school with a girl.
That was born on the same day, month, and year, then that is pretty, yeah.
That's pretty cool.
One of
Well,
my
you
neighbors
increase
was
your
born the same hour,
chances.
in the
Holy,
same hospital, on the same floor, in the same hallway.
Oh,
Yeah.
okay.
That's crazy.
I know, that is kind of crazy.
My mom and her were friends.
They're probably really twins. and
Yeah.
got all
I
that.
Yeah,
Yes.
yeah.
I know, that is kind of crazy. It happens, but then for y'all to meet and know each other,
In a small town.
right,
you're
it's more,
like,
yeah. That
my
is-
mother, way back 50s plus years ago, shared a room, because that's how they did the hospitals then. And I went to school with the girl that my mother shared the hospital room with.
Hey,
So we had
actually,
the same birthday.
I'm born almost 40 weeks after Valentine's Day. My birthday's November 16th. So there's a higher probability
True that,
that
yeah.
babies are born around my
Exactly.
birthday.
birthday.
And after a snowstorm.
There you go.
After a
Or
snowstorm.
a hurricane or whatever.
Anything that makes you be in the house, I guess.
So what month is your birthday in?
November 16th.
My baby born February 15th.
Gotcha. Things you learn in math class. All right. Now, when you have a lot of, like what you were just saying, you're counting a bunch of stuff and you wanna know, how do I do 365 days in October, 70, and 365 days in 71, and 365 days. This is talking about how to count a bunch of possibilities. So, if I'm flipping a coin, and then I'm flipping another coin, and then I'm flipping another coin, and I wanna know how many different ways can I flip 3 coins? Or how many different ways can I toss a dice, and another dice, and another dice, and another dice, or whatever. The way that you're gonna figure out how many outcomes there are, how many possibilities are there to flip the first coin?
6.
2.
Oh,
Either
sorry.
you're gonna
I was
get a
thinking
heads,
dice. I'm sorry.
or you're gonna get a tails, right? For your second coin, how many different options are there for just that second coin? 2. How many different options are there for just the third coin? 2. So if I want to know the total outcomes, I multiply those together. 2 times 2 is 4. 4 times 2 is 8. So that means there's going to be 8 total different answers. So if I told you to write down, and I'm just going to go to a different page right now. If I told you to flip 3 coins and write the answers, you're going to start going, okay, I know I have 3 coins, so let's do like a heads, tails, heads, 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 tails, tails, heads, heads. You're going to start writing them, and then you're going to say, do I have them all? Did I leave something out? So the easiest way to make sure that you have all of them is to say, okay, I have a coin, and a coin. The first coin has 2 options, either head or tail. The second coin has 2 options. The third coin has 2 options. So that means I'm going to come up with 8 answers. So I should have 1, 2, 3, 4, 5, 6, 7, 8 different answers. So when I write them, I have a method to my madness. I start out with all heads, and then I throw a tail into the mix. I put a tail at the front, a tail in the middle, and a tail at the back. Y'all with me? And then I put 2 tails in the front, 2 tails in the back, split the tails up. And then I do all tails. But you have to make sure, if not, you're going to drive yourself crazy going, did I leave something out? So doing this will tell you how many that you have to make sure that you have them all. So what if I flip a coin and roll a die? How many outcomes should I have for my answer? How many choices are there for flipping a coin? 2. How many outcomes are there for rolling a die? 6. So how many answers should I have if I write them? 12. So that means I know the answer before I even start. So that means I would have like a head on the coin with a 1 on the die. A head on the coin with a 2 on the die. A head on the coin with a 3 on the die. A head with a 4. A head with a 5. A head with a 6. Then a tail with a 1, a tail with a 2, a tail with a 3, a tail with a 4, a tail with a 5, a tail with a 6. And right there, I have my 12 answers. So counting the outcomes, counting the answers, lets you know how many you should have before you even start. So that's called counting outcomes. Let me come back to here for a second. And that's what this talks about. We're doing a coin and a coin. So it would be a coin times a coin. There's 2 options for a coin and 2 options for a coin, which means there's 4 answers. So they kind of did, I started out with a head and then I went with another head. I started out with a head and I went with a tail. And then I went with a tail head and then a tail tail. So these are going to be my 4 different answers. They just did it kind of with a tree diagram. But you just have to have a method to your madness to make sure that you come up with all different ones. And y'all, these are 2 different ones. You rolled a head first and then a tail. You rolled a tail first and then a head. Those are 2 different ones. Now, this is 3 coins, which is the one that I just did. They did a coin times a coin times a coin, so they knew that there was gonna be 8 different answers. And like I said, they did it with a tree diagram where I just did it kind of, so however you do it, you just gotta make sure you have all of the different answers. Alright. How many outcomes are there if you do a die and a coin? 6 times 2, which is 12. Must have known these notes too well. 6 times 2 is 12, and then they've already listed them out, which I did on the previous page. Alright, what is the probability? When I hear the word probability, that means what makes me happy over total. Of getting snake eyes when 2 fair dice are rolled. So if you roll 2 dice and you get a 1 here and a 1 here, they call that snake eyes because it looks like 2 eyes looking at you. Now, what makes me happy over total? So the first thing I've got to do is figure out how many total possibilities there are. Well, y'all, I'm rolling a die and a die because it says 2 dice. So if it's a die and a die, how many options are there for the first dice? 6. How many are there for the second dice? 6. So how many total options are there? 36. So my bottom number is going to be 36. What do you think my first number's, top number is going to be?
2. Would it be 2? Because it would be die 1 with a 1, and die 2 with a 1, and die 2 with a 1, and die 1 with a 1.
We're going to talk about it because we're going to be doing the cards and the dice. They get everybody. So here's the best way to look at it. For die 1, you have a 1, 2, 3, 4, 5, and 6. For die 2, you have a 1, 2, 3, 4, 5, and 6. So I can roll a 1 and 1, a 1 and 2, a 1 and 3, a 1 and 4, a 1 and 5, a 1 and 6. Let me move these over a little bit so I can have room to do. I can roll, it's kind of like a multiplication chart. I have,
There goes the 10 again.
I know, oh crap. Sorry. Hold on, let me see if it'll. Let me erase first. Then I have,
It needs new battery.
need some. It's like if I hover over it and not even touch it, it's, so 2, 1,
It's having a nervous breakdown.
yeah.
What are the probabilities?
Hold on, let me see if I can do, let me see if I can find one that I can suck over. 2 dice. Yes, you can find anything on the internet.
You can't use it for example.
No, let me see if I can get this right here, that way I don't have to.
Oh, no.
Alright, let me pull this. Put it right there so you can see it. So this is showing me that my first dice can be any of those numbers, and my second dice can be any of these numbers. So I can roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Or a 2 with a 1, a 2 with a 2, or a 6 with a 1. So we said 36. So if I do 1, 2, 3, 4, 5, 6, 12, blah, 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 these are my 36 answers.
Right.
Okay? Just like we listed heads, 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 tails, tails, heads. These are my 36 answers. How many of those 36 answers contains snake eyes? 1, 1. 1. So there's only one answer that has my snake eyes. So the probability of getting a snake eyes is 1/36. Now, have we all heard lucky number 7?
Yes.
7 is not lucky per se. It's statistically high. If you look on this chart, see how these add up to 7? And these add up to 7, and these add up to 7, and these add up to 7. There are 1, 2, 3, 4, 5, 6 numbers. 6 of the 36 add up to 7. So the probability of getting a 7 is the highest. So you're more likely to get a 7. So it's lucky. Your chances of getting a 7 are luckier. Now, if I was a betting person, I would bet on 7, not because it's lucky, but because it appears more often, so your probability's higher, so the percentage of you getting it is higher. And if you notice, after 7, the next luckiest number is going to be 8 or 6, because that's the next most. If I was told to bet on, I'll give you $100 if you are going to bet on blah, 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 I would not bet on snake eyes or a 12, because those are the least likely to get. So 7's not lucky, y'all. Just got good probability. Yes, ma'am.
I'm just gonna say, because like I went to the gas station like last week and a guy actually draw a 7, you know, from those little like ticket, like scratch off things. And he won about $600 or maybe $700.
Sometimes it's lucky, sometimes it's not. I don't play. All right, what is the probability? So right there is screaming, what makes me happy over total? In a randomly selected family with 3 children. So the first thing I'm realizing is we're having a kid, and a kid. So we need to figure out how many total different combinations we have. So y'all, when that first kid pops out, how many choices are there?
2.
Assuming there's no he, she children, we're either going to have a boy or a girl. When that second youngin pops out, how many choices are there? 2. When that third kid pops out, how many choices are there?
2.
So how many total combinations can I have? 2 times 2 is 4, 4 times 2 is 8. So my total is going to be 8. You with me? So what is the probability that the oldest child is a boy, the second child is a girl, and the youngest child is a girl, assuming that boys and girls are equally likely? So I know that there's 8 combinations. So if I were to list them, I'm going to do the same way. Let me pull down so that I have some room. So if I were to list those 8 kids, I'm going to do it kind of like I did with the heads and tails. I have a girl, so I'm going to start off with all girls. I'm going to throw one boy in the mix. I'm going to put a boy as the first child, a boy as the middle child, and a boy as the back child. You with me? Then I'm going to, so this was my one boy. Then I'm going to throw in 2 boys. I put 2 boys in the front children, 2 boys in the back children, and then I split up the boys. And then heaven forbid if I would have had all boys. I would have shot myself.
No, I love it.
I know, I could not have had boys though. Yeah, my husband had a son. I know, my husband had a son and I have a daughter. And my husband said if I would have had a daughter, I would have killed myself, even though he loves Madison to death. But he said boys are so much easier to raise. And my daughter says, when she grows up, she said, I ain't having a girl. And I said, baby, you can't pick. And she said, Mama, girls are too full of drama. And she just turned 12 last week. She said, Mama, I don't know how you do it, but I want a boy.
I bet you look at her like,
I know.
Girls are
this coming from?
loud,
I know.
boys are mean.
Okay, so these are our 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's where I'm getting my bottom number from. That's my total. So now I've just got to figure out what makes me happy. So the oldest child is a boy. The second child is a girl. And the youngest child is a